Hello and welcome guys to Get Alert channel. This is a problem solving session. Problems are very important for GATE. The main session today dedicated for solving the problems. Now look at this question. This question is a GATE previous year GATE question. This is asking GATE 2014. Now look at this question. Given an instance of the student's relation, student ID, student name, student email, student age, CPI. These are all the attributes. Now these are the values given. Now you can look at this. They were asking that the student name, student age to be the key, then X should not be. They are asking. If let us say the X value is some 18. First of all, what is a key? With key, what we can do? We can uniquely determine a row, right? With key we can uniquely determine a row. So if student name and student age is the key, then with that we should uniquely able to determine a row. Let us say if X is 19, for example, X is 19, this row and this row, student name and student age, Shankar, here also Shankar is there. Here 19, here 19. The two rows, the key value is same. That can't be the key, na? So X value should not be 19. If X value is something that says 17, 18, some 25, then these two rows will be different. We can uniquely able to identify them with these two attributes as a key. So the answer for this question is X should not be equal to 19. That's all. This is a GATE question. You have solved it. Now let's discuss another question. Now observe this question. This is second question. This question says that consider the relation R, ABCDE, functional dependencies are AB to ABC, BCD, CE. The number of super keys in relation RR. They are asking like this. So this question is based on the concept of super keys and candidate keys. So if you want to understand this question, look at my previous lectures. In that lectures, I have detailedly explained about candidate key, super key, what is the difference between candidate key and super key. So I am solving it here. First, we need to know they are asking the number of super keys in relation R. First, let us do the closure of AB. We need to do the closure of AB. What we can get? We can get A, B. With B we can get C. With C we can get E, D. With D we can get E. So we can say AB is a candidate key. Now if you want to do for A, if you want to do for C, let us say C plus. We are gonna get C, and C will determine E. So we are gonna get D, E also, like this. But C is not a candidate key because with C we can't get all the attributes now. So C is not a candidate key, but AB is a candidate key. Now if AB is a candidate key, we need to check some other candidate keys also possible. Let us do BC. BC closure, first B will come, C will come obviously. With BC we can determine D now. With D we can determine something else, no. With C we can determine E. But we can't get A anyhow, that's all is completed. We can't get A. So this is not candidate key. This is not candidate key. So there is only one candidate key for the relation. If you want, you can try many possibilities, but at the end you will get this only. This is the only candidate key of the relation. So possibilities are like this. You need to do the problem in this way. It is generally, if you do the whole method, it will be time consuming. The shortest approach is you write this A, then B. AB is a candidate key, so AB is also super key. Remaining 3 spaces are empty. How many attributes are there? A, B, C, D, E. So AB is a candidate key, so AB is a super key. ABC is also super key. ABCD is also super key. Like this, like that, how many possibilities will come? They are asking like this, the number of super keys. So I am going to do it in this way. First, I am taking C variable, C attribute. We can place C here or we can't place C here. So we can place C here, that is the one possibility. We can't place C here, that is another possibility. So 2 possibilities are there for this place. This is the permutation combinations. Let us take D. D can be placed here, D cannot be placed here. The 2 possibilities are there. So the 2 possibilities have been came here. Let us take E. E can be placed here, E cannot be placed here. In both ways, that is the correct only. So here also 2 possibilities are there. Total how many possibilities will be there? That is 2 into 2 into 2. That is 2 cube, that is 8. So total 8 super keys will be there. This is a good question. This is asking GATE 2022, very recent year question. Now let us look at another question in more or less similar way. Now take a look at this question. The maximum number of super keys for relation R, E, F, G, H are the attributes with E as a key. The key is given and they are asking the maximum number of super keys. This is asked in GATE 2014. This is a very simple question. If you look at my previous lectures, you can easily do this question. There is a direct formula for it. How many attributes are there? 4 attributes are there. So maximum number of super keys, that is equal to 2 to the power of n minus 1, means what? 2 to the power of 4 minus 1, that is equal to cube, that is equal to 8. So 8 super keys are possible for this relation. That's all. This is 2014 question, very simple. But if you rather go with the normal approach, it will take so much time. Generally, you remember this formula, you can solve this type of questions. Maximum, where n is the number of attributes. This is the answer. Now you try these questions for the next. These are the good questions. Now I have written it like this, but understand is like this. This part is there for this question. This is the part same for this question also. Means relation is this. This is the functional dependencies of one question. They are asking how many super keys are there. This is the same relation and functional dependencies are different. They are asking how many super keys are there. If you can able to solve this question, that means your concept is clear. That's all. And thank you for watching this lecture. And in next lecture, we will discuss some more concepts.